Hello, in this presentation I will explain how can you find domain of a function, and I will give you different example with radicals as well. So let us start with very easy example. Let us say I have a function fx is equals to function x is equals to 2x minus 5. This is my linear function. So for any linear function, the domain is always negative infinity to positive infinity, and this is how we write. Let us see one more example. F of x is equals to x square plus 3x plus 7. Now this is quadratic, but if you do not have any fraction or square roots, in that case it will be again, domain will be again negative infinity to positive infinity. Let us see one more example. So for this one, again there is no fraction or square root, so in that case again the domain will be negative infinity to positive infinity. So these three examples were really very easy. Now let us go to little complex than these all examples. Let us say I have f of x is equals to 15 over x minus 3. Now we already know that divisor can never be 0. For an example, if I say 5 divided by 0, then in mathematics it is undefined. It means denominator cannot be 0. Make sure that that value doesn't make denominator 0. So if I take positive 3 for x is equals to 3, then that will make my denominator 0 because 3 minus 3 is 0. So I can take any value of x, but exception is 3. I cannot take 3. So here my domain will be something like this, d. Now again negative infinity, comma, less than 3. It means 3 is not included. When 3 is not included, we make like this. When 3 is included, we make like this. So here 3 is not included. So I will close the bracket like this. Union, we can take all the values more than positive 3 to positive infinity. Now we can represent this information on number line as well. I will not represent a lot of numbers on the number line, but I will explain in simplest possible language. So let us say this is my number line, and let us say I have 3 over here. So this will be, and it will go till infinity in positive side, and it will go till infinity in negative side. Here I have positive infinity, here I have negative infinity. So this is how you can represent. Now let us see more complex example. Let us solve this one, and in this problem I need to think same thing. My denominator cannot be 0. It means what are the values that I substitute in x square minus 5x plus 6, and that makes it 0. I cannot take that value in my domain. So let us think about this. So here if you know the factorization of quadratic, it will be very easy for you. I want two numbers. If I multiply, I get 6, positive 6, and if I add them, I get minus 5. So that numbers are very simple. Minus 3 minus 2, isn't it? If I multiply these two, I will get positive 6, and if I add these two, I will get negative 5. So both the conditions are fulfilled. So I can say this will be x minus 3, x minus 2, here let's say equals to 0, equals to 0. So I can say x minus 3 equals 0, x minus 2 equals 0. Add 3 both the sides, so that will be x is equals to 3 and x is equals to 2. So that means if I substitute 2 and 3 in this quadratic, then I will get 0. It means I cannot take 2 and 3 because I don't want my denominator 0. That means for my domain I can take any value that's greater than 3, any value that's less than 2, because these two are exceptions, and I can take all the values between 2 and 3. How can I represent this on a number line? So this is my number line. Let us say I have 2 here and I have 3 here. So I can take all the numbers greater than 3. So I will make open circle and take all the values greater than 3. Again I will make open circle and all the values less than 2. Apart from that, I can take these values also, because 2 and 3, two numbers are exception. I cannot take that. Anything other than that I can take. So these values will also be accepted. So this is how I can represent the information on number line. Now I want to write notation for this one. How can I write that? Very simple. I will write domain negative infinity to then 3 to positive infinity, and here I will do the union 3 to positive infinity, union 2 comma 3. This means 2 and 3 are not included, but all the values between that are included. So this is how you can write domain for this function. Let us solve this one, and again here we need to work on the denominator. Denominator cannot be 0. That's what I need to work on. So this is my x square plus 9. Now I need to think the value that I can put for x and it will make it 0. So here, even if you put minus 3, that will not make 0. Why? Because minus 3 power 2, it means minus 3 times minus 3. That's positive 9, and positive 9 and positive 9 is positive 18. Isn't it? So that will not make 0. So when you have exponent 2, even if you take base negative, still it will make it positive because of exponent 2. So here there is no value that can make denominator 0. So in that case, my domain will be negative infinity to positive infinity. Isn't it? Solved. Let us solve this one. This is a little different, but I will explain in easiest language. Here we have square root, and inside square root we have x minus 9. Now we have to make sure that this value never goes in negative. Why? Because in mathematics, square root of negative is undefined. So there cannot be the negative value. So here if I replace this x by 9, that's okay. That will make it 0. If I replace this x by 10, that will make 1. If I replace this x by 11, that will make 2. So that means I can take any value including 9 and more than 9, isn't it? So here I can write my domain like this. Now I will use this big bracket. Why? Because 9 is included. So 9, and it will go till positive infinity. Isn't it? So this is how you can solve this one. Let us solve this one. Again, we need to work on same thing, that in square root there cannot be the negative value. 0 is okay, greater than 0 is okay, but there cannot be the negative value. So first of all, I will do the factorization of this quadratic. This is x square plus 2x minus 24. Now I want two numbers. If I multiply, I get minus 24, and if I add them, I get 2. So that will be 6 and minus 4. 6 times minus 4 minus 24. 6 minus 4 will be plus 2. So both the conditions are fulfilled. So I can say this is x plus 6. This 6 is plus, and x minus 4. Let's say this makes 0. This makes 0. Now x plus 6 equals 0. X minus 4 equals 0. I will subtract 6 from both the sides. So that will be x is equals to minus 6. And this will be x is equals to plus 4. So that means if I substitute x is equals to minus 6, that will make it 0. And if I substitute x is equals to plus 4, that will make it 0. It means I can take 4 for x and all the values greater than 4 even, isn't it? 5, 6, because that will make 0 or bigger than 0, and that is accepted. Now let us think what happens if I substitute minus 6. So if I substitute minus 6 here, that will be 36, and then this will be minus 12. Minus 6 times 2, this is minus 24, and that's 0, isn't it? So minus 6 is accepted. Now let us check for minus 5. So if I put minus 5 here, that will be positive 25. If I put minus 5 here, that will be minus 10, and that will be minus 24. So this will be 25 minus 34, and that is negative, isn't it? So I cannot take minus 5. I cannot take even minus 4. I cannot take even minus 3. I cannot take minus 2, minus 1, 0, 1, 2 and 3. This will not give the desired value. Now let us check what happens if I plug minus 7 for x. So that will be 49 minus 14 minus 24. 49 minus 38. That's 11. So that's okay. And if I go minus 8, so that will again be positive, isn't it? So let us write domain for this one. Your domain will be something like this. You can go till negative infinity, starting from minus 6. So here minus 6 is included. So I will make it like this. Union starting from 4. You can go till positive infinity, isn't it? And you can represent this information on number line like this. Here let us say I have 4, and here let us say I have minus 6. Now we observed that here in between we get negative values, here we get positive values, and here also we get positive values. So positive values are accepted, and if we plug 4 and minus 6 into this, we will get 0. So that is also okay. So it will look like this. Here it's a closed circle, goes till infinity, closed circle, goes till infinity. Let us see one more example. Let us find domain for this one. Here we need to work on two things. First thing, I don't want my denominator 0. Here we have square root. So in square root 0 is accepted, but it's in the denominator, and in denominator 0 is not accepted. So for this one, and to think of the value that will be greater than 0, isn't it? So if I plug minus 5 for x, that will make 0. Now 0 is accepted in square root, but this is in the denominator, so in denominator 0 is not accepted. So we can say for this one, my domain will be all the values greater than minus 5. Minus 5 is not included because minus 5 will make it 0. So I'm making small bracket, and it can go till positive infinity. Now you might think, why I'm not going into negative? Negative will not be accepted in square root, isn't it? Because in mathematics it is undefined, so it will not be accepted. So negative will not be accepted, 0 will not be accepted. So I just need to think the value that will be greater than 0. So all the values greater than minus 5 till positive infinity. Even if I go for minus 6 here, that will make minus 1, isn't it? So I cannot take any value less than minus 5. Let us understand one more example. Let us solve this problem here. Let us start with the numerator. So in numerator, you can see you have this radical square root sign, and we already know in radicals, inside the radicals, negative values will not be accepted. So what happens if I put 5 here? That will be accepted because 5 minus 5 is 0, that is okay. So 5 is accepted. If I put 6 here, 6 is accepted. If I put 7 here, 7 is accepted. If I put 8 here, 8 is accepted. It means 5 or greater than 5, all the values are accepted. So for the numerator, let me write greater than or equal to 5, all the values are accepted. If you go in last, let us say you put 4 here, then 4 minus 5 will be minus 1. So that's going in negative, will not be accepted. So we have a conclusion for numerator that it should be 5 or greater. Let us think for denominator. In denominator, 0 will not be accepted. So if you put 6 here, then 6 square is 36, and 36 minus 36 is 0. But 6 will not be accepted because we don't want 0 in the denominator, that is undefined. So can I put 7 here? Yes, 7 will be accepted because 49 minus 36, that is something positive. What about minus 7? Yeah, minus 7 is also accepted because minus 7 times minus 7 will be the positive 49, same as this one. So minus 7 is also accepted, but we will not consider negative. Why? Because when you do the input in a function, let us say you do the input of minus 7, then this is minus 7 not accepted. If you put minus 7 here, minus 7 minus 5 will be minus 12, and that's a problem. This negative is not accepted inside square root. We need to do something that is accepted to all. So for denominator, we can say, we can take all the values greater than 6, but not the 6. Greater than 6, but not the 6. Now let us write a domain. That's very simple. For the domain, we can say, we can take 5. Why I am making big bracket? Because 5 is included. But we cannot take 6 because this 6 will make the denominator 0. That's not accepted. So I will make small bracket. Union, we can take all the values greater than 6 till infinity. I will make small bracket because 6 is not included, till positive infinity. So we did something that is accepted to both numerator and denominator because we have one input only. So whatever input we have, that should be accepted in whole function, isn't it? Let's see one more example. Let us solve this one. Let us think about the numerator again. So we have this square root symbol. So in radicals, there cannot be the negative number. So here, let's work on that problem. What happens if I replace this by 0? I will get positive 2. So that's accepted. What happens if I substitute 1 here? That's 3, accepted. What happens if I substitute minus 1 here? That will be plus 1. So minus 1 will also be accepted. What happens if I substitute minus 2? That will make 0. Yeah, that's also accepted. Minus 3 will not be accepted because minus 3 plus 2 will be minus 1. So we cannot go ahead here. But yeah, we can go ahead here. If I substitute 2, I will get 4. If I substitute 3, I will get 5, and goes on, goes on, goes on. So here I can conclude that all the values greater than or equal to minus 2 will be accepted for numerator. Now let us go to the denominator. So again, in denominator, 0 will not be accepted. So if I replace this x by 5, that will be 5 square minus 25. That's 25 minus 25 and 0. So 5 will not be accepted. 6, yes, because 6 times 6, 36, 36 minus 25. So that is okay. 6 will be accepted. 7 will be accepted. 8 will be accepted. So we can say 6, 7, 8 onwards, and same way we can say negative 6, negative 7, because that will be again positive. Minus 6 times minus 6, positive 36. So these negatives will also be accepted. As we saw on previous page, we must do something that is accepted to both numerator and denominator. So in numerator, can we go below minus 2? No. So there is no meaning of this, because we cannot go below minus 2, because if I plug in minus 3 here, that is minus 3 here, and that will make negative in this radical in the square root sign, and that is not accepted. I must do something that is accepted to all. So negatives are accepted, negative minus 6, negative minus 7, but that is not accepted the numerator, so just erase that. So now I will make two number lines for clear understanding. First of all, let us say I have this one, and here I have minus 2, and all the values greater than or equal to minus 2 will be accepted. Here I have closed the circle because this is included. Now I need to make another number line, that is for denominator. So in denominator I already erased what is not possible. Now let me make one number line for the denominator. So in the denominator, let us say I have minus 5 here and 5 here, but 5 is not included, so I will make open circle and it will go like this. And minus 5 is not included, so I'll make open circle again and it will go like this. But now we have to find intersection of these two, what is accepted in both. So here you can see this area, starting from this area accepted in both, isn't it? So my final domain will be like this, 5 not included, and anything more than 5 will be accepted, and it is common for both. And I can write domain like this, domain 5 is not included, so small bracket, and it can go till positive infinity. So this was the last example, and I tried to explain in as easy language as possible so you can do best in your test or assessment, whatever you have in your school. And I tried to take different examples so that everything is clear in your mind. Thanks for watching. If you like my video, don't forget to press the like button. Thanks for watching.